Hi, Science 30s. Mr. Riley here. Another quick organic chemistry video. We've been looking at functional groups. So when I take an alkane molecule and I add something to it, I can take away a hydrogen and add something else. We call that a functional group. We looked at halogens. We looked at hydroxyl groups, which make alcohols. And our next one here we're going to be looking at is something called carboxylic acids. These are very, very common weak acids. And what the functional group is, it is called a carboxyl group. And so this one is a little bit different than something that we've done before. And we're going to see that with a COOH. So you guys might have seen chemical formulas that end with a COOH. For example, vinegar. I'm just going to hop down here. Vinegar is an example of a carboxylic acid, and its formula is CH3COOH. So we see this COOH on the end of that. That tells us it has it's an organic acid with this carboxyl functional group, which gives it its acidic properties. So let's look at the naming first. So when I add this carboxyl group to a molecule, the end of my alkane name is going to be changed. I'm going to add to it at the end oic acid. And so if I had a 1 carbon carboxylic acid, it would be called meth. And so we're gonna drop the E from methane, and we're gonna add oic acid. So that would be the name for a 1 carbon carboxylic acid. Some other uses of these carboxylic acids: food additives for flavor. Something like citric acid would be used for that. The lactic acid that gets built up in your muscles when you work your muscles really hard and your body needs to take a little shortcut because there's not enough oxygen getting to your cells. It produces this waste product called lactic acid, which makes your muscles sore. Some vitamins are actually carboxylic acid. Vitamin C is an acid called ascorbic acid. And so let's look at an example here of some things I might ask you to do. So first one, okay, so the question here says draw butanoic acid. So first we got to think about what is the parent chain. So what's that but telling me? So the but is telling me, if I go look in my data booklet, that's the prefix for something that is 4 carbons. And this oic acid tells me on the end of that parent chain, I'm going to have this COOH thing happening. So let's draw the parent chain. So we're going to have 1, 2, 3, 4 carbons. And on one of the ends, and this can actually only happen on one of the ends, I'm going to have a double bond. Now, we haven't seen a double bond yet. In the regular course, we would have sort of looked at this already, but we're doing this online and we're trying to stick to the basics. But you remember oxygen can make a maximum of 2 bonds, and carbon can make 4. So we just want to remember that. Oxygen can make a single bond or a double bond. Carbon could make a single bond, a double bond, a triple bond. I mean, carbon could theoretically make a quadruple bond because it can make 4 bonds. Now, hydrogens, they're always on the outside of our molecule because hydrogens can only make 1 bond. So there's my CO, and now I need my OH for my COOH. So just like with an alcohol, this is going to look just the same as a hydroxyl group would. So this section right here that I'm circling right now is your COOH. That's your carboxyl group. And now I just got to fill in the rest of my hydrogens. All my carbons should have 4 bonds. All my oxygens should have 2 bonds, and all my hydrogens should have 1 bond. And if we look at that, we are all good. Okay. Now, if we want to go the other way, I'll show you a molecule, and you have to tell me what the name of the molecule is. So the first thing that you have to do is look at the parent chain. How many carbons are there in the parent chain of this molecule? So in this case, we have one here, one here, one here. We have 3. So 3, I know my prefix for that is prop. And now I notice here I have my C, my double bonded oxygen, and my OH here. So I know that because of this structure that's on the end of this molecule, that this is a carboxylic acid. So I have to use my naming. So this would be called prop. And then, so that's, I mean, propane is our parent chain. And then we're going to change the ending of this to oic, propanoic acid. Okay, so that's how you draw and how you name a carboxylic acid, and a couple other things about those. And next time we're going to be putting those 2 functional groups together, the last 2 that we did, and we're going to make something new. Okay, good luck.